So this is the question related to kinetics. It's some different question as compared to others. The student has asked me that, sir, this question is really confusing. I don't think so. The formula is going to work. So that's the question. In this question, there are three experiments. So H2O2, then we have H plus, then I minus, right? So first of all, I'm going to find out the order with respect to I minus. So for the I minus, I'm taking run 2 and run 3 because they have given us the different runs 1, 2, 3, 4. I have taken 2 and 3 for the iodide minus ions, right? Since in 1 and 2, H plus is same. So I'm not considering this. I'm not considering this, right? Sorry, in 2 and 3, they are the same. So I'm not considering this. And also they are approximately same. As you can see, 0.00105 is approximately equal to 0.0099. So they are the same. So I would not consider this. I would not consider this. I would only consider I minus ion, like, since you're looking that this is going to be doubled. So the rate also doubles, isn't it? So the rate also doubles. So I have taken like that. The concentration is doubled. So the rate is doubled. So it means with respect to I minus, the reaction is first order, right? Okay. Now for the H plus ion, now I'm going to find out the order with respect to H plus. I'm taking run 1 and 4, like this one and this one. Okay, since they are the same, so I would not consider H2O2. Okay, since you are looking, it's changing from 0.0198 to 0.0801, right? So it's going to increase by 4. So concentration is increasing by 4. It's changing from 0.0198 to 0.0801. It's exactly increases by 4. But rate is also increasing by 4. You can see it's mean that and from the previous record we knew that with respect to I minus, the reaction is first order. But the thing is that meanwhile H plus is getting halved. It's changing from 0.00105 to 0.00201. It's getting approximately halved. So now I have to check the effect on the rate. Now I have to check the effect on the rate, which I saw that when I minus is increasing by 4, so the rate is also increasing by 4. At the same time, the concentration of H plus is getting halved, but the effect of changing the concentration of H plus is absent, isn't it? When I'm getting halved, so why the rate is not changing? What does it mean? It's mean that the concentration of H2 or the concentration of H plus is not affecting the rate. So this is zero order. So this is zero order, right? Got it? I'm repeating. The rate is increasing by 4. Why? Because the concentration is increasing by 4. Meanwhile, I am changing the concentration of H plus. That is going to be halved, but the rate is unaffected. It's mean that the reaction is zero order with respect to H plus. Now we have H2O2. That's quite tricky as compared to others. For this one, I'm taking experiment 1 and 2. I would not consider it this is same. Now I'm going to take this one, right? So for H2O2, it's going to be halved. For I minus, it's going to be doubled. You can see. It's getting half, it's getting doubled. The rate is not changing. isn't it? 0.00181, 0.00181. Why? Because the effects are cancelling. Because the effects are cancelling. Because one is getting halved, another one is getting doubled, like that. The first one is getting half, the second one is getting doubled, so the overall effect is nothing. It's 1. That's why the rate is not changing. It's mean that when I would be working on that, I would say for H2O2 it's getting half, for I minus it's getting doubled. And we knew it from the previous record that the I minus is first order. So it's mean that when I minus double, so the rate should also be doubled, but in that case the rate is not changing. Why? Because the effects are cancelling each other. So I can say order with respect to H2O2 is first order. That's it. Okay?